Hello students, today we are going to see formal charge, right? What is formal charge? Formal charge is actually the difference between number of valence electrons and the number of electrons given to the atom in a Lewis structure. Okay, suppose first one we can see this one, NH4 plus. This is actually polyatomic ions. So polyatomic ions, this charge is given. So this is on the top plus. So this is the total charge of this all atoms, nitrogen, hydrogen, everything. But if you see CO3 2 minus, CO3 2 minus, this is the charge of all the atoms, right? But we can also calculate the formal charge for individual atoms. So let us see how we can calculate formal charge. So for example, let us see carbonate ion, CO3 2 minus, CO3 2 minus, right? So already in second video we have seen how to assign electron dot structure or Lewis dot structure for carbonate ions. So suppose some students, they are calculating which one, CO3 2 minus, that is in previous video we have given that one, still I am giving one example. So this is carbon, to complete the octet 8 plus, this is 3 atom, 3 into 8, so what is this one, 8 plus 24 is equal to 32. This is total number of electrons required to complete the octet configuration. Next one, B for valence electron. Carbon valence electron is 4 plus oxygen 3 into 6. Then 2 minus is there, so you add here 2. So this is actually 4 plus 2 is equal to 24 electrons. Okay. Next one, shared electron. What is shared electron? Total minus V, that is 32 minus 24 is equal to 8. So clear? The next one, what is unshared electron? Valence electron minus shared electron. So 24 minus 8 is equal to 16 electrons. So this is the shortcut method how to give Lewis dot structure for different ions. So different polyatomic ions. So according to this one, shared electrons 8. So I am giving C double bond O, single bond O. Right? So then unshared electron 16. So here already 2 it is there. So 1, 2, 3, 4. Here 2, 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4, 5, 6. So here 6, 4, 6, 10, then 16. See here, we are going to see formal charge for each atom in carbonate ion. So first one, this is different. This is carbon 1. Sorry, oxygen 1. This is oxygen 2. This oxygen and this oxygen, they are in same surrounding, same set of electrons. So first let us see formal charge for this one. So before that, somebody is doing electron dot structure for carbonate. They are trying this one. Suppose C. Then they are giving single bond, single bond, single bond O. So 1, 2, 3, 4, 5, 6. Oxygen 1, 2, 3, 4, 5, 6. This oxygen also 1, 2, 3, 4, 5, 6. So here is one 6, 3, 6, 18 plus what is this one 2, 4, 6. Then 24. 24 electrons. But you see here, this is octet completed, this is octet completed, this is also octet completed. What about carbon atom? Carbon atom 2 plus 2 plus 2. That means only 6 electrons are there. So in the case of carbon, octet is not completed, right? So according to this one, so first one in second video we have seen this one, same way we can give the electronic dot structure for carbonate carbonate ion. So this is not applicable, wrong structure. This is the correct structure. I think you understood this one. So now let us see what the formal charge. So formal charge formula is formal charge is equal to valence electron in free atom minus half into shared electron minus lone pair of electron. V is for valence electron. Valence electron in free atom. In free atom. Second one, S is shared electron. That means bonded shared electrons. L is lone pair. Lone pair. Lone pair of electrons. Lone pair electrons are non-bonding, or you can write here non-bonding electrons. Here how you can write shared electron, that is bonding electron. Okay, this is for bonding electrons. Bonding electrons. Okay, so first let us try for this one. Carbon we can see. What is for carbon? This is same set. These two are same. So first let us see for this one. This oxygen. Oxygen double bond 1. Oxygen 1 is equal to free atom valence electron is 6 minus half into shared electron. What is shared electron? Here 2. One bond is equal to 2 electrons. So 2, 4 into 4 minus non-bonded electron. How many are there? 4. So 6 minus this, you cut this one, 6 is equal to 0. So for this oxygen the charge is 0. So this is charge, formal charge is equal to formal charge is equal to 0. Right? Then you come to this one, this oxygen. This oxygen, how will you calculate formal charge? Oxygen 2 is equal to 6 minus half into what will come here? Paired, say shared electron 2, right? 2. Then minus non-bonding 6. So what you will get? 6 minus this cut 1. So 6 minus 7 is equal to 1. So this also same. This also single bond oxygen. So the oxygen number 2 and oxygen number 3. This one. Sorry, this is 3. So 2 and oxygen 3 also. They have what the charge? Minus 1 here. This also minus 1. Okay, now let us see for carbon atom. What is carbon atom? Carbon formal charge. Formal charge on carbon is equal to valence electron 4 in free atom minus half into what is shared electron? 2, 4, 6, 8. So it will cut this one 8. So is equal to 0. Okay, so actually when we study the formal charge, there is application is there. What is the application of the formal charge? We can understand stability of the molecule, the structure. We can, for one structure, for one polyatomic ion, we can draw various possible Lewis structures, but we select the Lewis structure which has least formal charge, that is almost near to 0 or nearest to 0. When those molecule as those structure, that will be the most stable structure. Okay, so first one, so this is actually formal charge for carbon is equal to 0. Now next one we can take for NO2 minus. This is example 1. Okay, carbonate ion. I think you understood this one. If you don't understand this one, now this how to calculate the electrons, see the previous video. The video I think 2, second video, I have given how to write different Lewis dot structures for different atoms, different polyatomic ions. Okay, now next we can go for which one? NO2 minus. When you see NO2 minus, okay, NO2 minus, NO2 minus, nitrite ion. So nitrite ion, what is coming here? N double bond O, single bond O. Here what will come here? Which one? Lone pairs 2. Okay, so this is one oxygen atom. So how will you write this one? 1, 2, 3, 4. Here 1, 2, 3, 4, 5, 6. So formal charge for this oxygen, formal charge for this oxygen, then we have to calculate the formal charge for nitrogen. So first one, for oxygen we have calculated 1 is equal to 0. The previous carbonate ion we calculated, per double bond oxygen the formal charge is 0. Next one, single bond oxygen, oxygen 2, oxygen 1. Next one is oxygen, second oxygen. So what this one, that also we have calculated, -1. How it will come -1? 6 minus half into 2 sorry, -6. So 6 minus 7 is equal to -1. Next one, in case of nitrogen, we go for nitrogen. Nitrogen, how it will come? Nitrogen formal charge is equal to 5 minus half into shared electron. What is shared electron? 2, here 3, 4, 6. Okay, the next one. So this what will come? 3 minus and lone pair 2. Okay, that what will come here? 0. Okay, the total charge you see here, this also 0, this also 0, then this is -1. So total charge is NO2 minus, right? Then we can go for SO4 2 minus ion. Okay, next example is for SO4, third one, SO4 2 minus ion. For SO4 2 minus ion, suppose one student is writing like this one structure, S, 1 here, 1 here, 1 here, 1 here. Actually, we'll write like this. That formula if you apply, we get like this one. So how many? What this one? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so when we calculate sulfate, so you can take SO4 2 minus valence electron, this is 6 plus 4 into 6 plus 2. So what is this one? 6 plus 24 plus 2, 32 electrons, right? 32 electrons you see here. Here how many are there? 6, 1, 2, 3, 4. So 24 electron. 24, 26, 28, 30, 32. Right? But you see now formal charge, all these oxygen are in same surroundings. Means they have same electron dot structure. Electron. So oxygen. What you will get for oxygen formal charge? Formal charge for oxygen, Fc for oxygen. How it is 1? 6 minus 1 by 2 into 2 minus 6. So is equal to -1. So this is -1, this is -1, this also -1, this also -1. So 4 minus 1. 4 minus. What about sulfur? You see, formal charge on sulfur is equal to, sulfur also belongs to oxygen family, right? So how will you write? Yes, 6 minus half into shared 8, 2, 4, 6, 8. So if you cut, what you will get? 6, 4 minus unpaired electron, no. So 6 minus 4 is equal to +2. Okay, for 4 oxygen -4. For sulfur how many is this one? +2. So total charge as a whole sulfate, what is the charge of this one? That is 2 minus. So this also correct valid Lewis structure. You see, this is valid Lewis structure. You cannot say it is wrong, it is Lewis structure. Okay, then we can go for this one. You see, sulfur belongs to which family, which period? Third period. We know third period elements, they can expand their octet. So we are giving the structure of sulfur is, you see, this also is sulfur. Yes, double bond O, single bond O, double bond O, single bond O. Okay, so here single bond 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4. Here how many will be there? 1, 2, 3, 4, 5, 6. Here I will be there 1, 2, 3, 4. Okay, already we studied for double bond oxygen. What this one charge will be? 0. Single bond oxygen formal charge is equal to -1. So how many single bond oxygen? -1, 2. -1 into 2 is equal to -2. Okay, now we go for sulfur. What is the formal charge for sulfur atom? Formal charge for sulfur atom. How will you write? 6 minus half into 2, 4, 6, 8, 10, 12. So when you put here 12, what will come here? 6 minus 6 is equal to 0. So the central atom whose formal charge is 0, here central atom formal charge is +2. So we already studied in Lewis structure which is the lowest possible formal charge, that means 0. So that will be more stable. So this also valid Lewis structure. This is Lewis structure, but this is more stable. More stable. So this is the exactly correct one. Okay, this is not wrong. We cannot tell it is, that is also valid structure. Among these two structures, which is most correct? The first, this structure. So this is the most stable Lewis dot structure for which one? Sulfate ion. Okay, suppose they are asking, just imagine, suppose they are asking, find out the formal charge for different atoms in sulfuric acid. Sulfuric acid, how will you write? H2SO4, sulfuric acid. So same structure, I am writing like this one, you see here. How will you write this one? Sulfur, sulfur double bond O, sulfur double bond O, you can write like this one. Yes, single bond O, here minus, no, you apply here H. Here O, here also H. Then here which one? Double bond O, here also double bond O. Then here 1 minus here also -1. This will be cancelled by this one. This also cancelled by this one. So if you want to calculate the formal charge for hydrogen, how will you calculate in this one? Formal charge for hydrogen is equal to valence electron 1 minus half into 2. So 1 minus 1 is equal to 0. So in this structure, so sulfuric acid, this is 0. This one, this hydrogen also will become 0. Okay, this also 0. So this also, how will be there? Which one? 0. So this is sulfuric acid structure. So when you want to draw the structure for oxyacids, first you have to draw the structure for anions. Okay, like sulfuric acid, sulfate anions. Then we can draw the corresponding acids. Is it clear? Okay. Now we'll do the another one, that is called, suppose we want to try the structure for nitric acid, HNO3. Okay, we can divide this one H plus NO3 minus. So here anion, that is nitrate ion. You see here, how will you draw the structure for nitrate ion? NO3 minus. See here, I am writing all the possible way. I think you will understand little better, more better than this one. You see, this structure is a very important. NO3 minus. NO3 minus. So first steps we are going for N, single bond O, single bond O, single bond O. So how for each oxygen? 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, this oxygen octet completed, this oxygen also octet completed, this oxygen also octet completed. But you see nitrogen 2, 4, 6. So this is not correct. This is, so we cannot take this one. Okay, then we go for other structure by using the formula N double bond O, single bond O and single bond O. So double bond O, what will come? 4 electrons. So 1, 2, 3, 4. Single bond O, how many will come? 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. Students, you see, now we are doing so many molecules. So double bond O means formal charge will be 0. Already we studied formal charge for this number 1, number 2, number 3. So formal charge for oxygen 1 is equal to 0. Formal charge for oxygen 2 is equal to -1. We already calculated oxygen 3 also is equal to -1. Right? Now we want to calculate for which one? For nitrogen. For nitrogen. Formal charge on nitrogen. Nitrogen is equal to valence electron 5 minus half into 2, 4, 6, 8. Then, then cut this one, you will get +1. You see, this is +1. Total charge +1. For 2 oxygen atom, -2. So what will come which one? -1. So this, when we write which one? NO3 -1. So this structure is 100% correct. Okay. Sometimes what students they do, no, they use, everyone have their own intelligence, no, so they try in different method. Okay, it is not. Let us see how this one. Suppose nitrogen. They give one nitrogen double bond O, nitrogen double bond O. Then they give here also one bond, oxygen. So how nitrogen valency 5. So here 1, that nitrogen valency 2 here, this also 3, 4, 5, 1 electron from this one, this one. So then they put this one here 1, 2, 3, 4, this also 1, 2, 3, 4, this also 1, 2, 3, 4, 5, 6, like this. I am asking, is it correct? No. Why it is not correct? Here you see nitrogen, that covalency. Here 1, 2, 3, 4, 5. So here nitrogen, they are forming 5 bonds. 5 bonds they form. Okay, nitrogen cannot form 5 bonds. Why? Because nitrogen's covalency can be extended up to 4. So this structure is absolutely wrong structure. So you cannot go for this structure. Okay, so these are, suppose nitric acid you have to draw. So what you can do is one same structure you can draw. Nitrogen double bond O, then what will come? Single bond O, then it will come single bond O, then here one, in this one you can connect one oxygen, sorry, one hydrogen H. So here 1, 2, 3, 4, 5, 6, 7, 8. Here also 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4. Here nitrogen, hydrogen what will come here? Here 1, 1, 2, 3, 4, 5, 6. Okay, for this hydrogen it will be 0. This hydrogen will be -1. Okay, this also 0. Okay, this how will you calculate this one for this oxygen? This is for oxygen, this oxygen, how it comes? 6 minus half into bonded. Bonded means here one bond will come. So 2, 4. Non-bonding pair 4, -4. So how it will come? This is 2, this also 0. So this also 0, hydrogen also 0, this also 0. Here here -1. The hydrogen, here nitrogen will have +1 charge. So +1 -1 cancel. So it will become neutral molecule HNO3, no charge. No charge. Children, see here, today we have studied formal charge. First you have to study what is formal charge. Okay, formal charge, the charge given to individual atom, but as a whole polyatomic ions, the charge is given for all the atoms. But here we are giving for each individual atom we are giving charge. So for neutral molecule like HNO3, or you can write one CH4, for neutral molecule there is no charge. Okay, last one, what is application? Application is what the application of formal charge. Application of formal charge. Application of formal charge is equal to, it gives the idea of stability of the molecule. I already told you, it gives the idea of stability of the molecule. Idea of stability. stability of the molecule or ions. Second one is what? Second one, we can give various structure for particular polyatomic ions out of various Lewis dot structure. The one which gives one whose value, whose formal charge is 0 or least number is the most stable one, most stable Lewis dot structure. Okay, students, you please practice these structures, then you will understand. Okay, then you go through this one. If you do not know carbonate ion, I have given some formula type. If you don't understand, go to the previous video and find out. You will understand this one. Okay, thank you.